Hello, learners. Do you know that data is the new oil? And all the data mining, data warehousing projects needed the data pre-processing techniques. Welcome to today's session on data pre-processing and why do we need and what are the different quality metrics we have. And this is a part of MCS 221 and MCS 226 courses. If you remember, in the last session, we have introduced the data mining, where we have defined the data mining as hidden patterns extraction. And also we saw the different processes of knowledge discovery in databases and followed by different applications of data mining. Today's session, I'm going to talk about what is data pre-processing is, why do we need data pre-processing, and not only that, we will also try to understand the difference between the noise and outliers. And that is one of the most frequently used words in the data pre-processing words. After that, we will be talking about the different metrics of data quality, followed by accuracy, completeness, consistency, timeliness, validity, and uniqueness. And then we will see what are the major tasks in the data pre-processing. We will see that how do we clean the data, how do we handle missing data, and followed by data integration, data reduction techniques, data transformation techniques, and then discretization and concept hierarchy. As we know that the data is the new nutrition of artificial intelligence. And when an artificial intelligence eats junk food, it is not going to perform very well. That is said by Matthew Emmerich. And what he says is, unless you have a quality data, you are not going to get the quality results. And that is what exactly we are going to discuss. Why do we exactly need the data pre-processing? So, in order to find the deep insight and draw some kind of conclusions and decision making, data pre-processing usually involves with the data examining. We have a data cleaning process. We need to manipulate. We need to do some kind of modeling. And it involves from the wide range of methodologies, including different applications from sciences, social sciences, and business worlds. And today's businesses usually benefits from data pre-processing because it adds value to more data-driven decisions and improving the operational efficiency. So now let's see what exactly the pre-processing is. So data pre-processing is a steps in the data mining and data analysis process, and that takes the raw data and transform it into a format which can be understood and analyzed by a computer and machine learning. So basically what it says is whatever the data we have, the real world data are very, very noisy. And whenever the real world data has to be processed, it has to be cleaned, it has to be manipulated, it has to be examined. Because unless you clean those data and transform those data in a related format, then only the final output is going to be very, very effective. Now, when we talk about data pre-processing, let's understand what was the actual problems in the heterogeneous information sources. Because those information sources, we need a data from the different locations. And every single location has a data in a different interfaces. They have a different kind of data representation form. They have a duplicate data, and these data are inconsistent. So while we are integrating the data from the heterogeneous sources, all these data has to be cleaned. All these data has to be pre-processed. And unless you pre-process this data, you're never going to get the quality results. Now let's understand why do we need data pre-processing. As mentioned here, data pre-processing is an important steps in the data science related applications. And when I say data science related applications, it's not only include the data mining, data warehousing, big data, artificial intelligence, all those comes under data science related applications. And this is one of the most important steps in all these applications. While you are building this application, this is one of the most important steps. And believe me, it takes almost more than 60% of your total time. That means if you have a quality data, you can always get the quality results. And because we know that real world data are very noisy, they are very messy, they are not in a format required. So all those has to be kept in the format which we actually needs. And as you can see in the diagram, we have a garbage data, and whenever you process through the different machine learning models, it always going to give you the garbage results. Not only it may contain some error, some kind of inconsistencies, but is often incomplete and does not have a regular or uniform design. And machines like to process nice and tidy information. So if you have a data in a structured data, like whole numbers or some kind of percentage, you always can do the processing easily. But because we know that today's real world data, most of these data are unstructured data. And when we have unstructured data, they might be in the form of image, they might be form of text or audio. It must first be cleaned and formatted before you are going for the analysis. And that is one of the most important reason why do we actually need this data pre-processing. So no quality data means no quality results. So all your quality decision must be based on the quality data. So all your systems like a data warehousing, data mining, data science or big data systems needs a consistent integration of all these quality data. As I mentioned earlier, because today's real world application required the integration of data from the heterogeneous sources. And while you are integrating the data from the heterogeneous sources, you have to keep it in the same format. You have to pre-process those data. You have to remove those noise. You have to keep in the same data format. So unless you keep those data in a quality data format, you're never going to get the quality results. Now let's understand the difference between noise and outliers. Noise refers to the modification of original values. You must have observed in the what they call some kind of television screen, some snow dots on that, or maybe you must have observed the distortion of a person's voice when he's talking on the very poor font systems, as shown in the diagram. And this is what exactly the noise is going to refer. So you might want to have a smooth data, but because of these real world data, which may happen due to any reasons, which may happen due to faulty instrument, because the data was not entered correctly, so the noise may occur with any reasons. Whereas when we talk about the outliers, outliers are the data objects with some kind of characteristics that considerably different than most of the other data objects in the data set. Now, for example, if you see the diagram here, you have a black dots and you have some dot which are also represented as a red dots with a red circle and all. Now you can see in this you have actually 4 clusters, one with a very big circle, one within the small black circle you have one more cluster coming, but there are 3 objects or 3 data objects which are not belonging to any of these data sets. That means neither they are belongs to one of these clusters, nor they are going to belongs to the any other clusters here. So in that case, those data objects are considered to be outliers. And there are many applications of identifying these outliers. For example, if whenever you talk about credit card fraud detection system, where you need to find the outliers in the name of person who is likely to going to do some kind of fraud. So in that case, you always looking for some kind of algorithms, you are always looking for some kind of techniques which can help you to find these outliers. Now, after understanding what is noise, what is outliers, what is data preprocessing, and why do we need data preprocessing, let's understand what are the different quality measures we have. Because information is only valuable if it is of high quality. So the question arises, how can you assess your data quality? So basically you have a many metrics, and I'm going to discuss few of those dimensions here. These are 6 dimensions: accuracy, completeness, consistency, timeliness, validity, and uniqueness. And when we talk about the accuracy, that means we are looking for whether the data is correct or not. How well does a piece of information reflects the realities? And when we talk about completeness, that means whether the data is not recorded, does it fulfill your expectation of what's comprehensive? And you have a consistency. Some data are modified at one place but not modified at the other places. Does information stored in one place match the relevant data stored elsewhere? And that is a question you have to ask yourself. So whenever you are building an application, you always have to see that whether the data is consistent or not. Because if you don't have a consistent data, you might get the wrong outputs. Coming to the next dimension, what we have is timeliness. And again, it's based on the users, because the user might need the present data, and while your database or data warehouse or storage might have old data. So whether your information available is timely updated or not, that is a question you have to ask. Validity is another matrix. Is information in a specific format does follows the business rule, or it has some unusable format? Or you have a uniqueness. Is this the only instance in which the information appears in the database? Because if you don't have a unique data, you might have to go to the duplicate data. For example, you might have some name coming as IGNOU, or in one place it is coming as IGNOU, or other place it might be coming as Indira Gandhi Open National University. Though both belongs to the same thing, but while you are updating in your database, you have to update in the same format. Otherwise, your machines or your system is always going to take them as a different objects. Now let's see all these dimensions one by one in more details. So when I say accuracy, the term accuracy actually refers to the degree to which the information accurately reflects an event or object described. For example, if I'm talking about the customer's age is 32, but your system says that it's 34, that means the information is not correct. It's actually not correct. So what steps can you take to improve your accuracy? Ask yourself whether the information represents the reality of the situation. So is there incorrect data that needs to be fixed? And based on that, you actually have to go for all these kind of accuracy parameters. And this is one of the most important parameters, or I will say metrics, which you always have to verify. And this has to be verified by the person who is actually collecting the data, who is actually entering the data. So if he says that the information is correct, and if the both places it's not matching, that means it's not correct. Now let's talk about the another matrix. What we have is the completeness. So data is considered complete when it fulfills expectation of comprehensiveness. That means you may ask the customer to supply his or her name, and you might take a customer middle name as optional, but As long as you have a first name and last name, your data is complete. So you can do to what you can do to improve this quality dimension. So you always want to assess whether the information is available or not, whether there are any missing elements in that. So based on those required information, you can always assess whether data is complete or not. Then we talk about consistency. Many companies, the same information may be stored at one place, but information matching, if it is matching, then it is going to be considered as a consistency. So if your human resources information system says that employee doesn't work here anymore, but yet your payroll information says that still he is receiving a check or salary, that means your data is inconsistent. And to solve these issues, you have to review your data set, whether you have the same instances everywhere. All this has to be matched. And again, the one who is collecting, one who is storing the data, he has to match these data, he has to verify these data, then only he can go for this consistency metrics. Then we talk about timeliness. So is your information available right when it is needed? For example, when we talk about you need some financial information every quarters, right? And if the data is ready when it is supposed to be, then it is timely. But for example, if you need a data of say 2021, and right now you have a data from only from 2022 to 2023, and your system doesn't have a data from 2020 to 2021, that means you don't have actually that timely update data. So in that case, what exactly you can do? Either you can store, you can always keep your data in the database. You can always maintain the historical data where you are going to maintain the data from the historical perspective. So if your customers or your users need the data in a timely fashion and that data is available in your database or data warehouse, you always say that it's a timeliness. But if does not have a data which requires immediate quarters data, if you don't have this, then you always have these data are not there. That means you can always fulfill those requirements. You can always go back and update your storage and database. Then next metrics what we talk about is the validity. So validity is the data quality dimension which refers to the information does not conform to a specific format, right? And very popular example on this is the birth date, right? So you must have observed this, like many system ask your birth date in a very specific format, right? And if you don't enter into a specific format, it says that it's not valid. So some system might say that you follow the DDYYMM. Some system might say that first you enter the date, then you enter the month, then you enter the year, right? So if your data quality meets these dimensions, your database, whatever the information you have, that means you actually meet this validity matrix. So you must check all this information and follow a specific format or specific business rules. So whenever you are going for a validity of the data, you have to follow a business rules. You have to follow a certain pattern which fulfills your criteria. Then you go for the uniqueness. So unique, as it says, that means there is only one instance of the data which is appearing in your database, right? For example, I have mentioned here Narendra Modi Damodar and Modi D Narendra may well be the same person. And because we know that if your system is considering this as a separate instance, that means you are possibility possibly you are going to have a duplicate datas. And while you are retrieving the data, while you are extracting the data from your database, so you might get the what you call not correct results. So based on that, you can always go and correct the data. So particularly you have to inspect your data sets. You actually have to see the data set and then update the data set accordingly. So if it is updated and your database is having the unique set of instances, definitely you doesn't require any such kind of removal of duplicate data and all. Then, after understanding the different quality metrics, starting from accuracy, completeness, timeliness, you have a uniqueness. All these quality metrics actually helps you to define the data qualities. So once your data is having the quality data, input data is a quality data, you always get the quality results. So while you are preparing your database, while you are selecting your different features for giving the inputs to your data model or machine learning model, you always has to perform this. Because as I said, unless you have a quality data, you don't get the quality results. So while performing these quality checks, you always has to see that all the metrics has to be followed, starting from the accuracy to completeness to till uniqueness. So all these quality parameters has to be followed. And once you have identified your quality inputs, you are always going to get the quality outputs. So now let's see what are the major tasks in the data pre-processing here. So when we talk about data pre-processing, we have a different steps, we have a different task here. So starting from data cleaning. So in the data cleaning task, what exactly we do is we try to fill in the missing values. Now one may question, how do we get the missing values? It might occur due to faulty instrument data collection, because whenever you are collecting a data, your instrument might have some kind of fault, and due to that your database or your input database might have a missing values, and these missing values has to be cleaned, because unless you clean these data and make the data quality input, you're never going to get the quality outputs. So you have a fill in missing values, you have a smooth noisy data, you have a different techniques for this actually. So you have to identify or remove the outliers and resolve all this consistency related issues. Then second task what we have is the data integration of multiple databases, either it is from the databases or data cubes or files. As I mentioned earlier, these databases, while you are integrating, these might be from the different sources. At one source, it might be in the form of SQL. Other source, you might have a data in the form of data cube, or in some other source, they might be maintaining the data in the form of files. So while you are integrating the data, you always has to make sure that you perform the data integration techniques, and every structures, every format, every features fall into the similar what you call variables. For example, we are talking about the student database, right? At one place, you might represent the student name as stu underscore name. Second place or second source, you might keep the data student name as s underscore name. And third place, you might have a student underscore name. Though all these variables are representing the same student name data, but because they are into a different data representation form, while you are integrating the data, you have to always transform into the single format only. So while you are integrating and loading the data into a data warehouse or some kind of database, you have to see that you actually follow a one format, and then you can always extract the data and load it there. Then you have a data transformation techniques. So transformation, there are different techniques for the data transformation. We have a normalization techniques, data aggregation techniques. What happens, many of your machine learning systems or data mining systems needs data in a very specific format, or I will say very specific ranges. For example, your real world data have data ranges from 100 to thousands, but your algorithms might need a data in a very specific range, say 0 to 1. So these normalization and aggregation techniques actually helps you to do that. Then you have a data reduction techniques. In data reduction techniques, you have a what you are going to do, you are going to always obtain the reduced representation in volumes, yet produces the similar analytical results. In discretization process, what exactly happen? It's a part of data reduction, but with a particular importance, and especially for the numerical data, we actually use this discretization and concept hierarchies. And this is what exactly one can see in the form of data pre-processing here. So you can see different tasks like data cleaning, data integration, data transformation, data reduction have been shown in this diagram. So especially if you come to the data transformation, we have transform -2, this 32, 100, 59 and 48. These are the input data. And after transformation, it has actually changed to -0.02, comma 0.32 and 1 and 0.59 and 0.48. So because we needed a data in a very specific range, this is what exactly we have done. So data reduction, you might observe this, that there were many rows and many attributes. This has been reduced. There are many techniques, data reduction techniques, which actually helps you to reduce the data volumes, but yet produces the same results. So with this, today's session, where we actually discuss about what exactly the data pre-processing is and why do we need a data pre-processing. We talked about different quality metrics, starting from accuracy, completeness, consistency, timeliness, validity, and uniqueness. So thank you very much. And if you have any questions, you can always contact us in the given address. You can always contact me on the address which I have shown you in the slides here, and you can always contact me on these numbers.
Do you wish to be part of a television studio